Now we want to graph a natural exponential function using a process similar to what we did in some previous examples. I plan on relying more in this example on transformations of the graph. So if we start with the graph of e to the x, so let me start by getting that on the page. The graph of e to the x is going to include the point 0, 1, and 1 comma whatever the base is, so in this case e. And e is about, let me write it here, 2.71828, a few more, but 2.7, for our purposes, I don't really need to go further than 2.7. Okay, so to get the graph of e to the x on the page, and I want to graph that in gray here. So it's going to include the point 0, 1 right here, and 1e, which is 1 about 2.7, so I'll just approximate it here. And it's got a horizontal asymptote at y equals 0. So a horizontal asymptote, I want to make that, on the x-axis right here. And so the graph looks something like that. Okay, this is our graph of y equals e to the x. Now, to get the graph of e to the negative x plus 2, a couple of things need to happen, a couple of transformations. The negative up there in the exponent, so negatives give us reflections, and if the negative is inside of the function, we need to reflect horizontally, like this way, so over the y-axis. And plus 2, so notice the plus 2 is not inside the exponent. The plus 2 is like after the fact, it's outside of the exponent. So that's a vertical shift up 2 units. So I want to focus on these 3 features, the 2 points, 0, 1, and 1e, and then the horizontal asymptote. And I want to do these 2 transformations to each of those features. So here, let's start with the horizontal asymptote at y equals 0. If I reflect that over the y-axis, well, it's already symmetric on either side of the y-axis. So reflecting it, it's gonna look the same. It's gonna reflect on it, like back on itself. Shift up 2, so that is gonna change things. So that whole horizontal asymptote, we pick it up, we shift it up 2 units. Now it's here at y equals 2. So for the graph of y equals e to the negative x plus 2, it's going to have a horizontal asymptote at y equals 2. Now let's also take the point. So there's this point at 0, 1. If we reflect that over the y-axis, well, it's right on top of the y-axis. So again, it just reflects onto itself. But then shift up 2, you're going to get a point right here. Does this. Okay, you get a point right here at, so it was at 0, 1, now it's at 0, 3. And then, one more thing, so this point at 1e, if we reflect that over the y-axis, now it's at negative 1e. And then from there, shift up 2 units. So basically add 2 to your y-coordinate, so now it's about 4.27. To be up here, because let's see, this is 1, 2, 3, 4.7. Yeah, about up here. Okay, so your graph should not cross the horizontal asymptote. These exponential functions are not going to cross the horizontal asymptote. It needs to go through these 2 points, so it's going to be something like this. It's got that same basic shape, except it's reflected horizontally and shifted up 2. So the graph in red would be the graph of this function, y equals negative x plus 2. Now you also might be asked about the domain and range for that function after you graph it. Domain for these exponential functions is going to be, generally, it's going to stay negative infinity to infinity. Unless you have something weird like a square root in the exponent, which you're not going to see. For the most part, the domains for these exponential functions, it's always going to be negative infinity to infinity. Now the range is affected by that horizontal asymptote. So the range of e to the x is 0 to infinity. The y is always positive. When you shift every point up 2 units, that's going to move all of your y coordinates up 2 units. So where you used to have y greater than or greater than 0, strictly greater than 0. Now, if you focus on the red graph, it covers y values from 2 to infinity. It never crosses this horizontal asymptote. So the y is never less than 2. Its lowest y is 2 with a parentheses because it doesn't actually ever touch the asymptote. It just gets really close to it, up to infinity. So there's your domain and range.